initially it is quite easy. So function operations, we're adding, subtracting, multiplying, and dividing functions, and then in a little while we'll be doing function composition. So this is just some different notation, f plus g of x. People think that is times by x, but it's not. F plus g of x means you have a function f of x plus a function g of x. That's it. Does everybody get it? So then f minus g of x is f of x minus g of x. Very simple. Just remember with subtraction to put parentheses around g of x because you got to distribute the negative. Then multiplication, f times g of x is f of x times g of x. And then f divided by g of x is simply f of x divided by g of x. And we know with division we can't divide by 0. So we're going to have to do all these and then say our domain. So that tends to be the hardest part for people. All right, the first thing I'm going to talk about with domain is stating the correct domain. When we have two problems, we're going to encounter two problems. The first one is when dealing with radicals that are even. Even radicals cannot have negative things underneath because then we would have I. We're not going to be dealing with i's, so we've got to restrict our domain accordingly. We've got to say x is going to be this so that we don't have i's. Does that make sense? So we can have, though, a 0 under a square root. Everybody needs to remember that. It is okay to have a 0 underneath a root. So the square root of 0, 0. That's fine. You just can't have a negative. So what you're going to do is just do algebra to figure out your domain if you're dealing with radicals. So look, the thing underneath has to be greater than or equal to 0, right? So my domain for this one is x is greater than or equal to 0. Let's look at this one. X minus 4 is the thing. So you'll set x minus 4 needs to be greater than or equal to 0. Add 4. X must be greater than or equal to 4. There's our domain for this one. Look, it wouldn't work if you plugged in, for example, negative 3 minus 4 is negative 7, which would be I. Do you see why this is a problem? Let's plug in 2. 2 minus 4 is negative 2. Do you see how that's an I? Okay, so one thing to note is you could see it in this notation or in interval notation. So if this was supposed to be an interval notation, you'd say 0 to infinity including 0. And then this one would be x values greater than or equal to 4. So you'd say bracket 4 to infinity since it does include 4. Okay, that's our first problem. The second problem comes when our denominator equals 0. We cannot have the denominator equal 0. So our second time we'll restrict is if we have a division problem. So right here we'd say x cannot be 2 and x cannot be negative 3. Now let's pretend I asked you to write that in interval notation. It can be any x value except 2 and except negative 3. So wouldn't it be true in interval notation to say negative infinity up to negative 3, not including negative 3, union from negative 3 up to 2 will work, not including negative 3, not including 2, union 2 to infinity. Now look, it kind of connects. Perfect. So it just depends on how they ask you to write it. So just depends. Okay. Let's begin. So now we're going to go back and you're going to be doing most of it on just either watching or if I ask you to do it on your paper or whiteboard or wherever. So just watch these first two. These first two are easy. So it says given f of x is this and g of x is this, find f plus g and f minus g. So we're going to do f plus g first. So f of x is 4x plus 7 and then plus g of x, the square root of x plus x. So combine like terms, 4x plus x, 5x plus the square root of x plus 7. Now think about it, it is in standard form because highest degree to lowest degree. Technically this is x to the 1/2. So 1/2 constant. Does everybody get what I'm saying? Okay, so I just leave it like this. So then where's the problem? A restriction is going to happen here since we have a radical. We have a radical. So isn't it true to say underneath the radical, x must be greater than or equal to 0. So our domain would be 0 to infinity. We can't plug in anything that is below 0 in this one, because then we'll have an I. Okay, ready, go. Do f minus g. subtraction, you need to distribute your negative. Okay, check your answer. You probably are there at this point. 3x minus root x plus 7. Okay, sweet. Don't forget to distribute your negative. What's my domain, everybody? Good. X is greater than or equal to 0 or 0 to infinity, including 0. Good point. All right, let's do some more. So let's look at this one. We're going to do f times g and f divided by g. So f times g. So f of x is x squared minus 9 times g of x, x plus 3. Now, technically, that is our answer because is factored form or standard form better? Not one is better than the other. However, I am going to go ahead and multiply this one out just for kicks and giggles. So that would be x cubed plus 3x squared minus 9x minus 27. Do you see a division problem or a radical? Do you see any potential problems? No. So our domain is all real numbers or negative infinity to infinity because there's not a division. It's not a division problem and it doesn't have a radical. You look confused. What's confusing you? Which part? So like if you look at the answer here, there's not a division problem, so we're not going to be dividing by 0, and then there's not a radical, so we can plug in, can't I plug in negative numbers and calculate it and not get i's? Does that make sense? No? Okay, good question. Okay, let's see if you guys are going to let me down like first hour, or if you're going to not let me down like second hour. So this one says do f divided by g. You guys do it. Ready, go. Okay, do you guys have an answer? Yeah. You do? You do? Sweet, what'd you get? What did you guys get in this middle group? Oh, no, group 4 got x minus 3. Did anyone else get that? Woohoo, you're right. X minus 3. Very good. Do we need to go over how to get that? Back to the top, back to the bottom, and divide out exact factors. But one little catch. You must restrict before you divide. Remember how big of a deal I made about that? Well, it's still a big deal. So our domain is x cannot be negative 3. If we were writing that in interval notation, we would say negative infinity up to negative 3, not including union, and then negative 3 to infinity. Sweet. Doing good. Way to go, guys. All right. All right, now we're going to talk about function composition, one of my favorites. So what we're doing is we're composing one function based on another function. We're taking a function and composing it of another function. Now remember what composing means. That means creating, correct? So you're going to take a function, you're going to plug it into another function, creating a new function. So the composition of function g with function f is written as GOF. So that is an open circle. That's not a time sign. You've got to make sure you keep the difference. So that's an open circle. It's G composed of F. Now that O is the word composed, but you're going to hear me use the little quick way of saying it is O. And it's defined as this. G of F of X is equal to G of F of X. Now here's what I'm going to explain, okay? If I said to you, find G of 3, wouldn't you take G and plug in a 3 wherever there's an X? Okay, so now if I change it and say G of F of X, wouldn't you take function F of X and plug it in to function G wherever there's an X, just like we did with 3? Okay, now here's a cute little trick. People always plug in the wrong thing. So look, G of F of X. How should I rewrite it so that it looks like this format? Because then we know we always plug in what's inside the parentheses, just like we did with our 3. So watch. Take X, squish it back in with F. That would be F of X. Squish it back in one more time. That would be G of F of X. So I just squished this backwards. Do you see what I did there? When you write it like that, then it's very obvious. I need to plug F of X into G of X. So let's look at this example now. HOG of X. Let's rewrite it in the better way. Squish x back in with g, that's g of x. Squish it back in one more time, h of g of x. We're going to substitute in g of x into h. So locate g of x. We're substituting that into function h everywhere that there's an x. So there's an x squared right there, so I have to plug in, instead of x, it's going to be 2x plus 3 squared. Does everybody get it? Now, we could multiply it out and put it in standard form, but standard form and factored form are equally good, so I'm going to stop. All good. What's the domain? Do you have a radical? No. Do you have a division problem? No. So the domain is all real numbers. Let's do this one. Now, we're going to do instead GOH of x. They're not necessarily going to be the same. Let's see if they are. Squish x back in with h. That's h of x. Squish it back in one more time. G of h of x. Do you see that I'm just squishing it backwards, everybody? So then plug in h of x into g wherever there's an x. So I locate h of x. It goes into function g wherever there's an x. So 2 times x squared plus 3. So wouldn't that be 2x squared plus 3? Domain is no problems. All real numbers. Am I right? Okay. Sweet. Hey, you guys do these. Oh, no, I'm going to show you one more, then I'm going to let you try one on your own. So now instead, it says given f of x is this and g of x is this, it wants GOF of -3. I'm going to show you 2 ways to do it. Way number 2 is the easier way. So watch way number 1, though. We could think of this as GOF of x, and then later plug in -3. So let's do this. That's f of x, g of f of x, correct? Squishing it back in. Plug f of x into function g wherever there's an x. So that'd be x minus 5 to the 2nd power. Now instead of an x, we want to plug in -3. -3 minus 5 squared. -8 squared is 64. That's way number 1. Now watch how much easier way number 2 is. Let's just literally think of this as squish -3 back in with f of -3, squish it back into g. What you're going to do is calculate from the inside out. So first, what is f at -3? -3 minus 5. -8. So aren't we really looking at g of -8? Now how do we do that? Don't we just plug -8 in for g? So that would be -8 squared, which is, do you see how that one was easier? You didn't have to do all the algebra. Okay, cool. Whatever way will work, though, you got the same answer. Okay, try these 2. Ready, set, go. Do we have an answer over here? What'd you get? 104. Very good. That is true. So you did g of -5, which would have been -10, wouldn't it have? So h of -10 would have been -10 squared plus 4, which is 104. You're awesome. How about FOG of A? Can you see my eyebrow moving? Okay, cool. What'd you get? What'd you get? A minus 3 squared, which is just as good as having it in standard form. So if you went as far as to say, yeah, they're both equal, but you did extra work if you did that, because not one is better than the other, unless in the instructions it says put your answer in standard form. Everybody agrees? Now, we would not talk about domain here because we're calculating a value. Right here it could ask domain, so our domain is all real numbers because there's no problemo. Okay. All right, now this is a cool problem actually, because I've actually encountered this in real life, and this is what I've seen on an ACT. So it's this. You have a coupon. I'll tell you the story about my real life experience in a minute. You have a coupon for $5 off of the price of any large pizza. You also come in, so you got sent in the mail, for example, $5 off a large pizza. You go in, and they're also having a 10% discount off of any pizza. So you're getting 2 discounts, right? We see this happen all the time in the real world. So it says, how much more would you pay for a large pizza if the cashier applies the coupon first? Now, how I've seen this on the ACT is they'll say, create an equation for both situations, and then they might ask which one, and then they might ask the difference. But I've seen them write the equations because that is a little bit more involved. So it says, so we don't know what the cost of the pizza is. So can we call X the cost of the pizza? Okay, now we're going to take, we can do this two ways. We can first take off $5, correct? And then once we do that, we can take the 10% discount. Now on the ECT, they will make sure to put 0.10. That is wrong. Why? Because if you take $10 and times it by 0.10, that's $1. That's a 90% discount. Does everybody see? It's not a 90% discount. It's a 10% discount. So what should we be multiplying by? 0.9. We're paying 90% of its worth. Okay, very good. That's way number one. Way number two would be taking the total cost of the pizza, taking that 90% off first. Sorry, taking that 10% off first, and then subtracting $5. So this would be the ones you would pick on the ACT, the one that is written correctly. They'll make sure to have a 0.10 on there for sure. Now it says, how much more would you pay for a large pizza if the cashier applies the coupon first? So let's put a number value on this. I don't know, let's make the pizza worth $10. How about it? Does that sound like a good deal? Take your calculator. 10 minus 5 times, okay, yeah. That's 0.90. $4.50. That's how much you're paying for that dang pizza. Let's see if they should have done this first. So $10 times 0.90 minus 5. $4. So which one would you rather them do first? That one. That's cheaper for you. Which one would the business rather you do? This one, right? They want to make more money. So our answer would be a 50% or 50 cent difference. Does that make sense? Because it said, how much more was the pizza if they apply the $5 discount first? 50 cents difference. Hey, now this is what happened in real life. So I literally did get in the mail a coupon for $20 off a pair of pants. And I went into the store and they were having a sale. And they did say you can apply multiple. A lot of times they'll restrict it for this reason. But they did say you can double up on discounts. At most 2 discounts on one purchase. So I took the pants up to the front and they had a 20% discount and then I had $20 off. And so I said, I heard them talking to each other, the 2 ladies behind the desk, and they were ringing it out. And the one lady said to the other lady, so will it matter if I take the $20 off first and then do the 20%? Like, and the lady's like, no, it doesn't matter. So I'm sitting there thinking, I'm going to wait. I'm going to hope they do the cheaper one, you know, because I know. So then secretly, I got the better value because I didn't say anything. Very dishonest, but you know, they said it. They said it. So, okay, so it's kind of cool. But if I would have said something, if they would have switched it, because I was watching carefully, if they would have switched it, I would have said, well, now, you know, can't we do the other way first? And then I'll say, I heard you say to her, it's not different. So, anyways, that's the cool story. Okay. Hey.
I can't take anything serious. No. No.
Say you're sorry. Okay. It's crooked, isn't it? Okay, ready, go. Do this one on a whiteboard. Okay, what's your answer? X minus 1? Okay, and then your domain was? Wouldn't our domain be -1? We can't divide by 0. If x plus 1's in the denominator, x cannot be -1. Good job for those that did that. Okay, good. Awesome job. We're going to get into some harder and harder ones. Okay. Let's talk about this one. So now getting into more advanced stuff. Now you have to remember from a couple units ago. So we have g of x on top, x squared plus 3x. And on bottom we have our h of x. Okay, so now that would be my answer. Now think about it. To state the domain, wouldn't it be better to have that factored? Well, let's get this all factored then, because we need to do that to simplify anyway. So let's factor the top. What do we do? What's the top? Okay, good point. We pull out an x, then left is x plus 3. Okay, on bottom, any suggestions? Pull out an x first. I like that you're pulling out what's in common first. So then left is x cubed plus 3x squared plus 3x plus 9. Now how do I continue factoring? Factor by grouping. 1, 2, 3, 4 terms means I need a factor by grouping. Very good. So we'll pull out x squared. Left is x plus 3. Pull out a positive 3, then left is x plus 3. So our safe haven's the same. So we're good. It does factor by grouping. So we would pull out x plus 3, and left is x squared plus 3. Okay, now watch, this restriction is interesting here. So our first restriction is x cannot be 0, negative 3, and then boom, something interesting happens here, and you will see this. So everybody think about it. Isn't it true to say that x squared plus 3 cannot be 0? Solve for x. Subtract 3. X squared cannot be negative 3. Square root both sides. So x cannot be plus or minus I root 3. Are we even going to have i's? No, so that's not a necessary restriction. There is no restriction there. The only way for us to get 0 is to plug in imaginary I root 3. And we're not going to be plugging in imaginary. So there is no restriction there. These are my only restrictions. So now we can divide out exact factors. So what's my answer? Way to not make the error of not saying 1. And then there's our domain. X cannot be 0 and negative 3, all real numbers. And I have full confidence you could then write that in interval notation. Just connect it all. Okay, that's still not the hardest domain. Okay, this is where we get a little bit more advanced. When we start dealing with both square roots and division, it is hard. So everybody, you should be taking some notes on your paper. Here we go. So first of all, let's do f times g of x and then state the domain. So this is just f of x times by g of x. So f of x is 2x, our g of x is square root of x minus 1. If you have multiple terms, make sure you use parentheses. So let's multiply this in. So 2x root x minus 2x. Isn't that all we can do here? Okay, now the potential problem here is the radical. So luckily this one's still an easy one. X must be good. It's greater than or equal to 0. That domain was easy. Okay, awesome. Let's do f divided by g. So f is 2x on bottom divided by g, root x minus 1. Now, you always, let's restrict or let's talk about domain before you do any simplification. Because if we want to be technical, and we're probably not going to, so we need to rationalize the denominator. Technically, yes? But let's do the restrictions of the domain right now. So now everybody look, there's a couple potential problems. There's problem number 1, a radical. And then problem number 2, we can't divide by 0. This is when it gets a lot more in depth, I should say. So let's restrict them individually and then put the restrictions together, kind of make them go together. So let's think about it. My first restriction is x must be greater than or equal to 0 from the radical, correct? My second restriction, isn't it a true statement to say the denominator cannot be 0? Now solve for x. It's just algebra, add 1. Square root of x cannot be 1. Square both sides, right? Square. So x cannot be 1. So then our domain is any x value that's greater than or equal to 0 is okay. But then x can't be 1, which is part of that. Isn't 1 part of this? So that's how our domain would be stated. We could even go like this, for example. So it starts at 0 up to 1, not including 1, right? Then it's united with 1 to infinity. Or writing it out separately would be like this. X value is greater than or equal to 0 as long as it's not 1. Not too bad still. Okay, this is where it gets yikes. Wait, is that our bell? Okay, you're going to see this again in calculus, so you might want to make yourself a little note. Refer back to me in calculus, because I even went and asked the calculus teacher how the best method of teaching this so that you'll remember it for next year. Okay, so we're doing f divided by g of x. So f of x is on top, square root of x, and then on bottom, g of x is the square root of 4 minus x squared. Now with this problem, that's the easy part. It's figuring out the domain because there are so many places we have to think about restricting on this one. So first of all, isn't it a problem to have a radical if you have a negative underneath? So for this one, we're going to kind of restrict separately and then put it all together like in that last example. X must be greater than or equal to 0 for that one, correct? Now let's look down here. There are two problems. We have a possible denominator to be 0, and then underneath has to be greater than or equal to 0. So let's do the easy one first. We know that the entire bottom, the square root of 4 minus x squared, cannot be 0. True statement. Solve for x, square both sides. 0 squared, 0. So we have 4 minus x squared cannot equal 0. Subtract 4, divide by negative 1, correct? So x squared cannot equal 4. So x cannot equal plus or minus, because we would square root both sides, plus or minus 2. So I'm going to just add that into my restrictions. X cannot be 2 and x cannot be negative 2. Does everybody see? Okay, this is where the hard part comes in. The hardest restriction, which we did not do very well in first hour. That's why I said that time. So we know that it's true to say this denominator underneath right here, underneath this radical, 4 minus x squared needs to be greater than or equal to 0. Am I right? Now watch what I'm going to do. You could use algebra. You could subtract 4, then divide by negative 1, correct? Or we could just add x squared over, couldn't we? So we have 4 is greater than or equal to x squared. So writing that in the proper way, really, that would be x squared. Look, make sure it stays eating 4, opening up on 4, less than or equal to 4. Does everybody see? Yes. Good point. So we're going to have to take that off. So yes, that's all going to come into play together. You're right. We should technically, she's saying, does everybody agree? We should just take off the equal to 0. Because we can't be 0. So let's do that. Good point. So now here's how we're going to solve this one. This is going to be an inequality, and with the quadratic, it's not as straightforward. So I guess I'm going to get this equal to 0 again. So x squared, subtract 4 from both sides, minus 4 needs to be less than 0. When is it less than 0? Solving a quadratic inequality, we have to make a number line. Remember doing that a long time ago? So make a number line, everybody. What are my zeros? I need to factor this. So this factors to be x plus 2, x minus 2. So what are my zeros? Yep, 2 and negative 2. So we're going to do negative 2 and 2 and test values to see what's in our domain. Does everybody remember kind of doing this? It was a long time ago, though. Let's test a value below negative 2. Plug it in. Let's plug in negative 3. Negative 3 squared. 9 minus 4 is 5 less than 0. No, so this is a no. That's not in our domain. Now let's test, I don't know, a value between negative 2 and 2 that's not 0, correct? 1. Or we could actually test 0, but 1 works. 1 squared is 1. 1 minus 4 is negative 3. Is negative 3 less than 0? So this is in our domain. And then let's test a value above 2, like 3. 3 squared is 9. 9 minus 4 is 5. Is 5 less than 0? No. So in our domain, right, for this piece, we have from negative 2 up to 2, we had a yes. Does everybody agree? Okay, now let's put all of that domain together here. So x has to be greater than 0, correct? So can we have negative 2? Somebody over here saying no. Can't have negative 2 because it has to be starting at greater than 0. Does everybody understand? Okay, so it has to be greater than 0 and then up to 2, not including 2. So our domain was from not including 0, so I need a parenthesis. 0 up to 2, was it including 2? Also, x cannot be 2, so 2 parentheses. From 0 to 2 is our domain. That was a hard one, huh? A little bit, just because there's a lot to think about. So there's our domain. From 0 up to 2. Are we all okay? Because we can't divide, because right here. Oh wait, should we even, oh right here. True, actually, isn't 0 okay? Isn't 0 okay right here? So actually we do need to go back and put a bracket, my bad. I should have caught that sooner. So this would have stayed or equal to. So this would have been included, but then we know we can't include -2 because also x must be greater than 0, so it can't be -2. That kind of makes sense. So do you see how it's kind of hard because you have to put all of them together? Let's do another one. They get easier with practice. Let's do another one. G divided by f. Now on top we have the square root of 4 minus x squared. And on bottom we have the square root of x. So let's do our restrictions here. They're going to be pretty similar, aren't they? So we know that it's true to say down here x must be greater than or equal to 0. True? For underneath? And it's also true to say the square root of x cannot be 0. Yep, so then x cannot be 0. So I now know for right now, isn't it true to say that x is only greater than 0 so far? And at the same time, right here, we're going to have a restriction. So we know that we're dealing with that same inequality. This must be greater than or equal to 0. So now we would have factored it to be -1, right? Pull out a -1. So negative x squared plus 4 is what we're looking at. Pull out a -1, then we're left with x squared minus 4. So then, if you think about it, the -1 won't matter, will it? Well, let's see. Actually, wouldn't we technically divide both sides by -1? So you got to flip the inequality. So we have x squared minus 4 is less than or equal to 0 again. So this factors to be x plus 2, x minus 2, same idea, is less than or equal to 0. So now we have our number line. Our zeros are at -2 and 2. And now we'll test values again, which we already know the answer, don't we? We just did it. Wasn't it a no, a yes, and a no? So then, right now we have this. X is greater than 0, and then from -2 up to 2. Am I right? Including? So let's put that together. If it has to be greater than 0, won't it start at 0 and go up to 2? But not including 0 in this one. It is not including 0 in this one. 0 up to 2. That's kind of hard. I agree. It's not quite exactly the same because notice the bracket on the first one was here where the bracket on this one is here. Okay, cool. Okay, you guys do this one. Ready, set, go. Do this on your paper or on a whiteboard. So squish x back in with g, that's g of x. Squish it back in one more time, f of g of x. So we're plugging in g of x into f. So now we have, instead of an x, we have the square root of 9 minus x squared, squared minus 9. Right? Now you've got to restrict, you guys, you've got to restrict before you do any simplification. So isn't it true to say, once again, 9 minus x squared must be greater than or equal to 0. I'm going to add x squared over, so that would be 9 is greater than or equal to x squared, putting it back in the prettier order. X squared is less than or equal to 9, because if it eats 9 here, it's got to stay eating 9. Then I'm going to do this. Solving an inequality with a quadratic is not as straightforward. We've got to go back and factor it and do our number line thing. So we would subtract 9, x squared minus 9 is less than or equal to 0. So now you would factor it, x plus 3, x minus 3. Let's see what's in our domain. Try your number line. Find the 0, since that's what we're looking for. When is it less than or equal to 0? So -3, and 3. Plug in a value, like less than -3. -4 squared, 16 minus 9, is that less than 0? And then from -3 up to 3, will that be a yes? Let's plug in 0. 0 squared minus 9, is that less than or equal to 0? Yes, that's in our domain. And then once again, 3, let's plug in 4, that works. Does 4 work? It doesn't work because it's less than, so no. So now, once again, is it including 0? So these little guys are yeses because it includes 0. Those are the zeros. So you say our domain is from -3 up to 3. Now we can simplify. That's just our domain. Now we can simplify. Root cancels out with power. So then we have 9 minus x squared minus 9, which is -x squared. Do you see how if you found the domain now, you would say no restrictions, which is not true. But you gotta do the domain before. Make sense? Okay? Hey, all right, all you smarty pants out there, I want you to tell me, write a function, h of x is equal to 1 over x minus 2 squared as a composition of two functions. Ready, go. There's many different answers. So guys, it's like literally saying, okay, I'm going to let f of x, for example, this is just one of the many options I saw that you guys came up with. 1 over x, and then let g of x be, I don't know, they said x minus 2 squared, for example. And then they said, okay, to create h of x, I'm going to have to plug g into f. So that would be f o g, wouldn't it? Does everybody see how that would work? Because then that would be taking g, plugging it into f. Another one I saw was people said let f of x be 1 over x squared. Let g of x equal x minus 2. And then they said same thing, f o g. Or they wrote it like this, f of g of x. We need to plug that in there. There was other options I saw last hour as well, but we're just going to move on. Does that make sense of what I was asking? Hey, ready, set, go. Do these three. Do FOG, GOF, FOS. Did you get X for the first one? Good. FOS. FOS. Okay, did you get this? FOF? Kind of interesting. So this is how I show them to do it in regular because a lot of them can't just see it. So I teach them to write it out like they have f of x twice because it kind of helps people see. So we're doing FOF. So we're taking f of x and plugging it in for x. Does everybody see what I did? So then you're going to cube root, and then instead of an x, you have the cube root of x minus 1, and then we have our minus 1 there. So if you need to write it out twice and do that, that's fine. Now, that's not going to simplify, correct? And then think about it, with our domain here, cube roots, odd roots are all real numbers. We can plug in anything, right? Negatives are fine, even positives are fine. So domain on all of these is all real numbers. Okay. Okay, let's do another one where the domain's a little harder. So, let's just do f plus g, everybody. Just watch because the domain's the hard part. So we have the square root of x squared minus 4 plus x squared over x plus 1. I don't care. I don't need you to get a common denominator and put it all together. Let's just leave it there and state the domain because that's the hardest part is the domain. So first of all, x cannot be -1, because then we divide by 0. Our second restriction is, isn't it true to say, I'm going to write down here, x squared minus 4 must be greater than or equal to 0. We factor it, x minus 2, x plus 2, so that we can actually find the zeros. Our zeros are at 2 and at -2. Let's test values. Let's plug in -3 squared is 9. 9 minus 4 is 5. Is 5 greater than 0? So yes, that's in our domain. Then right here in between is going to be a 0 squared minus 4. Is -4 greater than or equal to 0? Not in our domain. Plug in, I don't know, 3. Same thing as we got here. 5 is greater than 0. So yes, that's in our domain. So our domain here is, now is it including -2 on this? Equal to 0? So these little guys are yeses as well, correct? They're included in the domain. So we have this as part of our domain. And then we're going to say from -infinity up to -2, bracket, union from 2 to infinity. Am I right? Now, do we even need to list x cannot be -1? Is that even in our domain? Nope. So yes, that's true. We don't need to list it though, because that is taking care of it. Because -1 is in that section that we jumped over. Does that make sense, everybody? Woohoo! We're so smart. Okay, cool. I think you guys get the picture. Okay, let's do one more here. Do f divided by g of x and find the domain for me. The hardest part's the domain. Now, technically, you could rationalize the denominator, but let's tell our domain restrictions first. So we cannot, our two restrictions are, oh, that's a squared. No, it's not. This one's not too shabby, since it's not squared. That one's actually quite easy, isn't it? Okay, yeah, we'll check and see. The first is 1 minus x must be greater than or equal to 0. Subtract 1, am I right? Subtract 1, divide by -1. So we need to change our inequality if we do the algebra that way. Or we could add x over. So we're going to have x is less than or equal to 1. And then also it's true to say the square root of 1 minus x must be greater than or equal to, not equal to, just greater than 0. Solve for, oh, you know what? What I meant to say is cannot be 0. Sorry, I'm like thinking still about this. So then we square both sides. So x cannot be what? Square both sides, subtract 1. So x cannot be 1. So now we would just say, what's our domain? If it can't be 1, good to know. It's just x value is less than 1 then, correct? There's our domain. And technically, that's our answer, but we would then rationalize the denominator, if you will. Yeah. Do you want me to finish rationalizing to show you how you would write the final answer? Okay, just watch then, because yeah, just watch. Or you can take notes on whatever you want. Okay, so we would multiply by the square root of 1 minus x. Square root of 1 minus x. 2 terms means I need parentheses. So now on top, I would have x squared times the square root of 1 minus x plus 6 square roots of 1 minus x, right? Now we can't put these together. This is an x squared square root of 1 minus x, and this is a 6 square root of 1 minus x. We can't put them together. Then on bottom we have 1 minus x. Did you get that?
Why do you? Okay.
Okay, I'm practicing. No, I'm practicing. Okay. Good. Hey, what I want you to do is pick a few on the worksheet. Just like jump around, see some, like, oh, I better check some, like, there's some good ones on the back there. And flip around, find whatever ones you want to do. This is not sleep and just chit-chat time. Practice some.